We are working on reviewing exponent properties. In the last video, we reviewed lots of the rules. In this video, we're going to review one more rule, a rule that involves equations. So this is going to review how do I solve some simple equations that involve exponents in it. And so the rule is if you can put it in this format where your bases are the same, and of course your bases cannot be 1 because 1 to any exponent is just 1, so that doesn't apply. But if we can put this in the form where the bases are the same and they're not 1, then basically we know that our exponents have to be equal. And so we can kind of drop the bases and just solve the equation of where the exponents are equal to each other. So I have an example of this. If f of x is equal to 5 to the power of x squared plus 2x, we want to find all the values such that when our equation is equal to 125. So basically we want to know when is f of x equal to f of x, or when is this equal to this. So that's how we set up our equation. When is 5 to the x squared plus 2x equivalent to 125? Now, this is one that can be simplified very easy because we can apply this rule here. There will be equations that involve exponents in it that I cannot apply this rule to, so we'll have to solve those a different route. But since I can manipulate this to be in that format, then I can go about it this way. The question is I know this base is 5 here, and so how do I write my 125 as a base of 5? And that's really easy because 5 to the third power is 125. So that's why this is an easier one, so I can rewrite it that my bases are the same. Since my bases are the same, that's the first part of our rule, then that means we can basically drop the bases and just worry about where our exponents are equal to each other. So where is x squared plus 2x equal to 3? Well, this just reduces it down just to a typical polynomial equation, quadratic polynomial equation. So I know the steps to that are first setting it equal to 0, and then solving it by whatever method we choose, factoring, quadratic formula, or completing the square, or anything else. I'm going to choose to factor this, x plus 3x minus 1. And so when I set each of these factors equal to 0, I get the solutions of -3 and 1. And so if I were to find all values that when these equations are equal to each other, here's my two solutions, -3 and 1. Now we can double check this by quite a few ways. If we wanted to check it algebraically, we could substitute those values back in. So this is called back substitution. Substitute them back in to make sure that our equations are, in fact, equivalent. Or another way that we can check this is by graphing this. And so we can set the y1 equal to the left-hand side of our equation and our y2 equal to the right-hand side of the equation, and we can figure out where these two equations intersect. And so that's a couple of different ways that we can solve to make sure that we got the correct solution here. I'm going to let you do that on your own, and then we're going to move on with learning more about exponential functions.